So let's look at how this plays out for different confidence levels. So I've got up here different confidence levels that you might use. It's not a complete list. You can choose other ones. We said for 95% the z-star value is 1.96. And the way that arises more or less is you'd like to find in a z distribution 95% of the values fall between 1.96 and minus 1.96. And if that's 95%, that leaves 5% on each side. And half that 5% is 0.25. That upper tail probability, we're going to call it alpha. So for 95% confidence, that uses up 95% of the probability. There's 5% split in half here to get the tail probability. So to get the tail probability, you take the 100 minus the confidence level. It's like 100 minus 95 to get the 5%. And divide it in half because it's split among the two tails. And convert that to a percentage. So that puts this table in some kind of context. Now if we go to 98%, then we would need the region encompassed between plus or minus a z value to be 98% of the total probability that goes with z. And if we consult the tables, or a table of critical values, that z is 2.326. So in order to get 98% of the z values, I have to go plus or minus 2.326, so somewhat more than 2 standard deviations away from the mean. If I do that for 98%, that leaves 2% unaccounted for. Each tail has 1% in it. So there's the tail probability that goes with it. So there'd be 0.01 there and 0.01 there. And then if I went all the way to 99%, it turns out the z you have to go 2.576 standard deviations on each side of 0 for a standard normal, or just 2.56 standard deviations for a normal distribution to capture 99% of the values. It's 99%, but you have the two tails. There's 1% left, split in half, so that probability is 0.01 divided by 2, 0.005. So I should say tail probability, ordinarily called alpha. Okay, like that. And then another way to describe the tail probability is the probability that z exceeds that critical value z star. So for 1.96, the chance of being bigger than 1.96 is 0.25, and so on. Because it's just one tail, and the two tails together add up to be 1 minus the confidence level. So here we have all those things sort of laid out. Here are the 3 different confidence levels. Here are the 3 different z values that go with it, so that's z star. And the tail probabilities corresponding to those values. As you work your way further and further out in the tail of the distribution, the tail probabilities get smaller and smaller. So we should be in business. Table C will show you the critical values. It's a little bit cumbersome to use because for table C, up on top here, for reasons that will become clear later, we've got the confidence level. And then there's a bunch of stuff in here which we don't know what it is yet. And down here, we've got the z-star critical values corresponding to it. So if you go to 95% up here, and you slide down here, you get 1.96 in table C. So table C lets you look up all the popular critical values that people use, if we need them. And I'm sure if you're looking at the homework, it'll link you to table C, so you're able to grab a hold of those if you want. It's harder to find them in the normal z tables because you won't find exactly the probability you're interested in. And look it up backwards, it's not going to show exactly what the table C has that all worked out for you. Alright, let's see what happens next.